Hello and welcome to the channel. In this video we are going to discuss the math class. We kind of went through methods now, so we kind of understand how methods work and what overloaded methods are and stuff like that. And the math class has a bunch of methods that are available for us to use. Now the Java library comes with things like the system.out, print, and you can see as soon as we hit the dot, it brings up this little panel here that will give you kind of suggestions of what is available inside the system.out class per se, or the that object, I guess you could say. So it's taking a little bit of time here, so let me see if I can rewrite that. System.out. Okay, well, we'll just say print line. All right, so we know this one. We've been using this quite often throughout our programs. It's just one that you can call without having to, create a instance of it like we did with the scanner. Just remember when we did this, we would have to say, scanner is equal to a new scanner. Well, these ones here, you don't have to do it. And math is the same way. It's just allowed to be used without actually creating an instance of it. And the math is simply just math and then the period. Now there's a bunch of things that come with it. So when we're looking at a couple things that I can talk about quick are the constants. There's constant variables, constant values that are always there that you can use, and one of them is the constant pi. Okay, so that is an actual method inside of it. It is the constant, and it will have the equivalent of pi, so this would actually be something like 3.14, and then it'll give you the maybe up to the 10th or 10 digits after. I'm not exactly sure 100% on the digits. If you want to know the digits 100%, we can either send it to the print and you can see exactly what's going on, and that's just it's a better representation of pi. So if you're doing something that circumference or something like that takes the value of pi in consideration, it'd be smart for you to use this math.pi variable. I'll show you here. See how it has the most, it'll be a more accurate answer for you when you're using it. So normally when we do it in our math, we just use a 3.14, right? And that's still fine. If you choose that way, then that's okay for you to do that. But this will give you a little bit more exact of an answer, and it's kind of the Java way of giving you a little bit of extras to work with, constants that are available to you. You can assign it to a value, but you don't need to. It is already in essence, it is already a variable. So if you want to just use it in your equations, then just use it. I'm just going to assign it to a value just so we don't get an error, and I can kind of continue through. Another constant variable is the e, and that's for the natural e. We can pop this down here, and when you're looking at like compound interest, stuff like that, if you gotta use it, you'll know when to use it. You'll get like, oh, I can't have that there. Oh, I can, just ending statement. So that's a natural e. Normally you would use probably 2.71, maybe 828 would be a normal one, but this again, it's the same as the pi. It just gives you a more accurate representation of the natural e figure. So different things with like logarithms and stuff like that, but nonetheless, I'm not going to go too crazy into depth on each of those for you. So now the next couple that we have when we're working in, say, trigonometric or trigonomic methods. If you're working in trig, then you can definitely take advantage of these. We have the sine, okay, and there's the math dot cosine. There's the math dot tangent, okay, and then you have the inverse of each of these as well. So we'll just copy these quickly, put them in here, and to get the inverse it would be just an a. So a sine, a tangent, a cosine, and they take a double and they return a double. Okay, so when you're doing this, you're gonna need to store it in a double. in order to get it, unless you're printing it directly to the screen. You can put it inside here, but it returns it to the print, so that's how that would work. But if you're trying to do it in mathematics, you're going to have to assign it to a double to return, and it takes a double in here, so 5.66 or something like that, or 5.6. It could be, you know, anything that's a floating point value, stuff like that. All right, that'll all work perfectly fine with it. We can do the same thing with all these. Now, they're not just subject to you only putting in a double. You can put in an int value. It will resolve it for you. That's not a big deal. You can also do like full out equations inside if you needed to, okay, because this will resolve. Again, if you're going to pull this off, be sure to know your order of operations. So if you needed this divided before this was multiplied, then be sure to put in your brackets and be sure that you do your order of operations properly, like so. And you don't necessarily need to, it's just you don't necessarily need to put this full equation. You can resolve your math and then do so, use the method accordingly, but just for your own purpose, just know the different usages of them. All right, so that's each of the trigonomic methods. There's one that we got, math. So we got math dot 2 radians, and what this will do is take a degree like 270 degrees, and it will put it into the form of a radian. So we'll just run that quick. I'll show you what that's going to do. And you'll see that it just takes this and puts it into more of a decimal form. Okay, so that's pretty straightforward. Most of these are working in radians, so you'll kind of have an understanding of what's going on there. We also have the 2 degrees. So okay, so now if we were to take this number here and pop it in there, and then we just quickly, we'll just do a quick print using this guy. It'll actually take the radian number and produce a degree for you. So if in the case that you need to, see there's the degrees put out. If you need to, that's, you know, one way of going about doing things like that. So those are kind of your trigonometric or trigonometry type functions. The other ones we have is when working with exponents, and these ones are probably going to be a little bit more used. Each one has its own exponent method. Yeah, I think that's right. Each one has its own usage. Obviously, you'll know when you're doing your mathematics when to use each one. But the first one in the trigonometric, or I meant sorry, in the exponential fields are going to be the exponent one itself. So math.exponent, and what this is actually taking this e value here and raising it to whatever you put in here. Okay, so you're getting 2.71828, and then we would be raising it to the power of 5. All right, so that's technically what that does. It returns a double value as well. So again, this would be kind of what you would expect to put. You would hold it like so. Again, if you were to, you know, if I just went like this, change this to an int, said result underscore int. All right. Oh yeah, you can't hold a double in an int. All right. You cannot, you know, hand it over to an integer. So just be sure to make it a double when it works in that way. There's a couple that do actually produce an integer value, but we won't worry about that at the moment. So you have the exponent, and that is now raising this e to the power of 5. All right, and we can, you know, if you really needed to see an example of it, I could pop it into here and just raise it to the power of 1 and run it. And you see we get that same value for e, because obviously anything just to the power of 1 is itself. So that is this value. All right, so you're just basically raising e to whatever power is in the value here. We have now the, oh, we don't need to do that right now. We have the math dot log, and this is for your logarithms and stuff. If you're working in those, you can use it for you know, evaluating logarithms. Math dot log 10, that'll be your base 10 logarithm. I'm not going to get too crazy into the details of all this. You can look at the math tutorial set if you're kind of struggling with that, and you'll know with your equations that you get, or you know, hopefully you look up your own equations and you find out how it's working, or you know already, and you'll be able to just kind of plug these in and use them as needed type of deal, right? So the more useful ones that we're going to actually look at are probably going to be the math dot pow, and this is working when you're doing any kind of your own expressions with the powers. Okay, so it would technically say a and b. Now a is the base, so that would be, say, 2, and the b would be to the power that it's raised to. So if we said 2 to the power of 1, then we're obviously going to get just 2 when we put that in. So if we said pow here, we'll just type pow and we'll go 2 to the power of 1. All right, then you're going to raise, it'll essentially be the same as you putting in, you know, I'm just going to signify it like so. Just know that this is kind of the power raised to. And if we run it, you'll just see 2. All right, I'm just going to comment this line out so we just get that one. We can raise it to whatever power you wish, just kind of doing it for demonstration purposes. So as you can see, it returns a double value as well. Okay, so again, if you're going to use it, and these can also have, like this one here can also have an equation just put right into it. So if you had like 5 plus 4 times 30, you know, divided by 5, and you want to raise that all to the power of 5. Once this equation is evaluated, it will then raise it to the power of 5. And again, be sure to, you know, formulate this with the order of operations. If this needed to be added first, you're going to need to follow your order of operations and bracket that off, you know, and then maybe all of this had to be multiplied before it was divided, which in the case of order of operations, it should be anyways. So that's not really necessary, but if you're overwriting it, it's better than not and getting a proper result anyhow. So, but that's how the math dot pow would work. And then you have the math dot square root. Okay, and that one just takes a single double. You can do the same thing, 25 divided by 5 plus 6. You can do the same thing because it all resolves down to a single double or a single value, and then it's taken into consideration. All right, so again, just be sure of your order of operations, but this is to get the square root of a number. And those are pretty much the ones based upon any exponential or exponent type mathematics. All right, these two probably being your more so used ones quite often. That's probably your go-tos. So the other ones that we do have are rounding type, so rounding methods, and I'll go through a couple of them. I'll go through we have the math.seal. Okay, this one's kind of a different beast of its own. Now it takes in just a double, and what it's going to do is return the value to the nearest integer. So if we had 2.0, we're gonna resolve that to a 2. Okay, and that's pretty straightforward. But if you had 2.1, okay, I'm gonna show you a couple examples of this one. I'll delete this, and we had 2.1 here, and I'll go maybe with a 1.9. We'll do something like that. Okay, it's going to resolve it to the nearest integer, on the high end of that. All right, so I'll show you here. We have 2.1, we have 2.0, and we have 1.2. And at 2.1, when the ceiling went up, it went and resolved it to 3. Okay, so it kind of went that, because this is kind of on the way to, there we go, because it's on the way to 3, we'll just move it up to 3. And 2.0, you can see here, it still did the 2 because of it just having it is already a whole integer technically without anything. And the 1.9 also went to 2. All right, and the same thing would go if this was a 0.5. It's just going at anything with a decimal after it, it's going to bring it straight up. Okay, and then the opposite to that would be the math.floor. All right, and it works in the same premise. We'll just put, say, 3.0 here. So same premise here. If we changed all these to floor, now you'll see a very different way this works. And you're gonna want to watch when you work these and then know exactly how they're working. There is a better version of this. So these do have a time and place, but be sure to know when to use it properly. So you'll see this one now, because this is 2.1, it'll resolve to a 2. This will still be a 2, and this will actually drop itself to a 1. All right, and you see that in the output here. So the floor will just take it and round it down to the nearest integer, regardless of, if this is a 5 or if this is a 4 type of thing. It's just going like this is a 1, it just takes it right down. This is a 9, it drops it all the way to 1. All right, you think it would, but that's just how that one works. And now the guy that's kind of in the middle of all these would be the rint. All right, and this one's kind of a little bit of a weird duck, but it's still decent. So if we said rint here, okay, I'm going to change these up a little bit now, just because how this is going to work for us. If you were to take, say, this was make this 2.45, this one 2.0, and this one 2.4. Oh, 2.4, okay. And actually what we'll do is we'll go this one with 5, that one with 4, this one with 6. Okay, that'll be kind of a better arrangement for us to look into. As you can see, with the 6, it brings you up to 3. With the 2, it actually brings it down. Okay, so it's kind of the middle range one. Not necessarily the one you're going to look at using in those forms, but it's just it's one of the middle range types for the thing. That's the best way I can explain it to you. It does have a very different explanation to it, but it's kind of what it is. So the other ones that we have available in here are actually the math.round. Okay, this one's a little bit more intuitive, probably the one you're going to use on the most part. And you can see here, I'm just going to find it in the actual list. It is an overloaded method, so it takes a double or a float, still being a floating point value. And what it's going to do now is this one at the math round, and this one is a more of an accurate representation of what's going to happen. Okay, so if we take round and go round, okay, this is like rounding to the nearest integer. Whereas say this one here, we got these exact same values in here. We'll just run this now. And see, we get 2.6 resolves to a 3, 2.5 resolves actually to a 3, okay, and then 2.4 resolves to a 2. So that's kind of where you're going to look at it a little bit more. You'll probably use this guy quite often more than any of the others. It seems to be more accurate when it comes down to just the way it does its rounding. So if you do need to round, then that's probably going to be the way that you go about doing this. It's not really like formatting. Formatting would be different in the form of, you know, if you wanted to get 2 or 3 decimal places, and you're not going to essentially round it up or down. But like Canadian math now, there's no penny, so it works upon the fact that you know, if it's a 5, it goes up. If it's a 4, it goes down. So in those regards, it's just the way that the math in Canada now works, type of thing. So that's fine. Those are probably more so what you're going to be looking into. And then we got these other kind of weird offsets of it. Oh, we'll leave this guy up here. And now this one here is, I'm not even really sure. We'll call them the min, the max, and the absolute, or the abs. Okay. And how these work is pretty straightforward. The min will now be it takes in 2 parameters, and what it's going to do is just return the lesser of the numbers. So if we got that one, comma, and you say 6.54, it's going to take this into consideration, and it's just going to now return the lesser of the 2. All right, so we can do, just kind of rewrite these so we don't see different things here. I'll just put this maybe at 8 or 7, this one at we'll just go 5.23 and do something like that. And you can see it doesn't actually take more parameters than just the 2, so just be sure of that when you're doing it. But so that's the min, and you'll see that it just gives us 5.23, 6.54, and then it's obviously 5.23 because there's no minimum value. Okay, so it just returns the min. The max is now the exact same thing, but just the opposite form of that. So if you said max at this point, and we just did the max here, it would then take and evaluate the 2 numbers and just return the maximum value of the 2 numbers, or the higher value of the 2. So that's how that works. All right, so again, this is max, so yes, we are now producing the maximum of the 2 values. And the abs is the absolute value. That'll return the absolute. So this one here is kind of takes 1 parameter, like so. You're not going to be able to put in extra values, it just doesn't take it. So this one here is kind of it's useful for its own purpose. It's pretty much to just it's like the not operator when it comes down to it. So I'll put this in here and here, and you can see 5.65. If I put that to a negative, okay, I actually don't need any of those. If I had a negative value there, we run this, you'll see that this one here just returns 5.65 to it, but the one that had the negative now just gets the absolute, takes the negative value off of it and gives you the value without negative. Okay, so that's kind of what the absolute value is, retains it without negative. So and there's ways that you can go about doing that yourself if you know mathematics, but again, it's a method there that's available, so you can use it instead of having to do all the extra stuff yourself, type of deal. So that's those. These 2 will probably be more, well, they're all pretty handy. I'd say round is probably a handy one. The rint is equally as okay. The seal on the floor, kind of a weird one, depending on what you want out of that. Math Pow and square root are probably the more useful ones there. And depending on what you get into with that, you'll find these are handy as well. The last one we'll talk about really quickly is the math.random. And now this works off of getting you random number. So if you're looking, a lot of stuff actually looks, you know, games, stuff like that, you kind of want to do like a random number situation. And how this will work is it's going to return a double. For the most part, it returns a double. So we'll call it random underscore a. Okay, and then what happens with this is that it doesn't just, you're not going to be able to just take a random like so, because it's not really sure what's going on. It's not gonna, you got to kind of give it a range. So what you would do is you would say something like random times 10. Okay, and if we print out random a now, you'll see that it's actually going to be a number in decimal form, or in double decimal floating point form, and it's going to be a number between 1 and 9, or sorry, could very well be 0 and 9 as well. So in order to get that 10 in there, you're going to actually have to like add 1. I don't know really why. You can even put this to 11, I think, if you really want. Do that extra for yourself. It's just something that's weird like that. And if you want it to not be, if you want it to be like a whole number, because I mean, a lot of times a random decimal point isn't really all that helpful. You can do other things to it, like if you want to round it, you can do that, but for the most part, not necessarily that helpful. So you would just typecast it to an int, all right, and then we can store it in an int as well, and then we can just run this. I'll show you. It's a little bit nicer of a random number to work with, and it depends on the outcome of what you're looking to do and how you're looking to work it. All right, so if we went something like this, and we'll call this b, and then we'll just print out that one as well. So this is pretty good. I like the random numbers are something you're gonna probably use more, so, or you're gonna use that quite often, I find anyways. I figure that it's ran rather often, depending on what you're doing, I guess. So we got 1 and 0, we run it again. We got 1 and 0 again. It's not being too random at this point, eh? Oh, what's going on? So the random totally lost its randomness. It's kind of awkward. Oh, it was, I did that. It's not really being too random at the moment. 1 and 1. Not really sure why that messed up all of a sudden like that. Kind of being a pain. It's gonna give me 1 again. Well, isn't that weird? Oh, I know. Okay, so yeah, this is what we're gonna have to do. This, so you got to evaluate this first, and then typecast it, and that's where my problem went. So now it'll. Sorry, that was my bad. I forgot to. You have to evaluate this as an equation first. So what I did was I was actually typecasting the random to integer and not actually looking at the rest of the equation. So that was my fault. I kind of messed up there. But we can do this again, and we'll just do this with the 11. All right, and then there's so many different ways to do stuff in Java. All depends on you and the developer and kind of the way that you look at things and the abstract ways. So here we go. We'll get now two random numbers, 6 and 9. We can run it again, and you'll just get random numbers chose from in between 0 and 10 basically at this juncture. So you got 0 and you got 10, and you can keep going if you want and figure it out. But these are pretty fun. They're pretty cool. Card games, stuff like that. Selecting, like, you know, if you're making like a Sudoku, you can select the random numbers that are getting plugged in first and stuff, in order to make puzzle games or whatever it is that you're using it for. The random comes in quite handy and helpful. That's pretty much the gist of all the math classes. There's so many more that are in it, but the video will get way too long, so I'm just gonna end it right now. If you want, just type math and you can look through and see what is left there. If you need to kind of look it up, you can look at it and you can read through. Sometimes this isn't the easiest to understand, but a lot of the times you're not gonna you'll find a place when those come handy to you. These are pretty much the more well-known, well-used ones. There's probably a couple that I'm not really showing you, but as a basic tutorial set, I don't think you need to know too many of the higher stuff until you start learning higher level of programming as well. All right, so there's your constant variables when you need them. Not these guys, these are just fun for us to use. These are your constant variables that are available in the math class. These are all your trigonometry or trigonometric, trigonomic, or whatever you want to call it, however you want to say it. This is your exponent type methods. These are your ones when dealing with having to round numbers, seal them, floor them, kind of round it with an int, rounding your minimum, maximum, and absolute values, and this guy with the random, so math.random. Okay, this is kind of what you're going to do for the most part when it comes down to it. And we'll look more into this. We'll build little applications that have the random involved. We'll write applications that have all this stuff involved, basically, like power, square root, those ones for sure, rounding for sure, the random for sure, minimum, maximum. We can figure that out and do that too. And we'll probably end up later on getting into more of these functions as well, or not functions, sorry, methods. A method, procedure, and a function essentially are all the same thing. Java calls theirs methods. Other programming languages call them procedures or functions. And I always get it wrong whether or not a procedure returns something and a function doesn't, or if a function returns something and a procedure doesn't. But either or, that's kind of the gist of it. Methods are methods. Java's methods. All right. So that's it for this video. If you liked the video, give it a thumbs up. If you have any comments or questions about it, or have ideas for future videos, leave it in the comment section below. Be sure to subscribe, check out the rest of the channel, and we'll catch you in the next video.